Good morning, ladies and gentlemen, boys and girls, friends and neighbors. This is kind of a tough topic. We're going to be talking about rational functions today, but before we start talking about rational functions, I want to just have a quick review on fractions. And before I start talking about fractions, I'd just like to give a snapshot. I haven't gotten to the hairdresser lately because we're all locked in, quarantined, but my hair's grown out and I'm waiting to go to the hairdresser, get my hair cut. So we'll see. Hopefully you all are doing great. Let's get back to fractions. Okay, so before we can have a good discussion on rational functions, we have to talk about rational numbers, i.e. fractions. And just to review, and this is, I don't know, third grade, fourth grade standard. Here I have this guy right here. We're going to call that a fraction. A fraction is where a and b are integers. Fraction can be positive, fraction can be negative, fraction can be what? Zero. So this is very important. A fraction is zero. Like a fraction is equal to zero when a is zero, when the top of that fraction is zero and the bottom does not equal zero. We'll talk about what happens when the bottom does equal zero. Here's an example. 0 divided by 5 is 0. 0 divided by negative 99, by golly, is 0. So a fraction is 0 when the top is 0, when the top equals 0, and the bottom does not equal 0. When the top is 0 and the bottom is not, that's when a fraction is 0. Hello. And we're going to go down here. Hey, when is a fraction undefined? When you write a fraction, you say, what? That's not defined. A fraction is undefined when b is 0, period. When the bottom is 0, that fraction is undefined, period. You can't talk about it because it's not real. Division by 0 is undefined, and that's what we're talking about because a fraction is division. Division by 0 is undefined. So that's going to be very important in our discussion about rational functions. Here's an example. 7 divided by 0. Undefined. 0, yes, that does not equal 0. 0 over 0 is undefined, and then we have another term for that in calculus. We call that's indeterminable. But for us right now, in Algebra 2, 0 over 0 is going to be undefined. Why? Because the bottom is 0. Negative 4 over 0 is undefined. So we have a very quick review of fractions. When a fraction is 0, a fraction is 0. When the top is 0 and the bottom is not, a fraction is undefined when the bottom is 0. Divisible by 0 does not exist. So let's go to our first example about a rational function. So a rational function is, do you see this? It's a quotient of two polynomials. And we're going to start with two really easy polynomials, this x minus 3 and x plus 5. These are very easy polynomials. But a rational function is a quotient. It's a quotient of two polynomials. And for our first example, we're going to go real easy. We're going to talk about this quotient of two linear functions, the quotient of x minus 3 over x plus 5. Please don't try to cancel the x's. They don't cancel. You can only cancel factors, not add-ins. Okay, so the first thing we're going to do, and the first thing we did when we ever analyzed any functions, we had quadratic functions, we did a little bit of square root functions. The first thing we do is we find out the domain of the function. So the domain of this function is going to be all real numbers except when what? Except when x plus 5 is equal to 0. Why? Because you cannot divide by 0. So the domain is all real numbers except when x plus 5 is equal to 0, i.e. when x is equal to negative 5. So here's how I'm going to write the domain. The domain, I'm going to write it all x such that x, by golly, does not equal negative 5. That's the domain. In our IXL that's associated with these rational functions, we're going to call x equals -5, and they're going to call it an excluded value. Excluded value, because it's excluded from the domain. And I've never called it excluded value, but that's not a bad term for it. It's kind of fitting. It's excluded. X equals -5 is excluded from the domain of that. That's the excluded value. We're going to wait to talk about the range of this function until probably pre-calculus. The other thing that we've done, and we've done well, is we find the y-intercept. How do you find the y-intercept of any function? You let x equal 0. Come back here. You let x equal 0. And if I put 0 into that function, what the heck am I going to get? I'm going to get 0 minus 3 over 0 plus 5. What is 0 minus 3? -3. What is 0 plus 5? 5. So that's my y-intercept is 0, -3/5. Okay? Y-intercept, domain, y-intercept, easy. Hey, this stuff is pretty easy. Put 0. What about the x-intercept? X-intercepts happen. When do they happen? They happen when the function is equal to 0, i.e. when y, because we know that we always let y equal the f of x. Well, the function gives us the output. The output of the function is the y, and our f of x is equal to x minus 3 over x plus 5. Let's get that little dot out of here. It's driving me crazy. X minus 3. So I want to know when this guy here is 0. I want to know, because if I want to find the x-intercept, I need to know when y is equal to 0. Well, y is equal to that, so I ask myself a question. When is this guy right here equal to 0? Oh, wait a minute. When does a fraction equal 0? A fraction is equal to 0 when the top is 0 and the bottom does not. That's what we're going to use here. So where I'm going to go here. When is that rascal equal to 0? Oh, when is the top 0? The top is 0 when x is equal to 3. Why? Because 3, what are you doing? Because 3 minus 3 over 3 plus 5, if I put 3 into that function, is going to be 0 over 8, which is equal to 0. So the x-intercept, you betcha, is going to be 3, 0. The other thing we're going to talk about here, and I think on the next slide, all I did was reiterate what I've done. Yeah, so the excluded value, x equals 5, x equals -5, sorry. And I have the y-intercept, I have the x-intercept. What I'm going to do now is I'm just going to look at the graph of this with my graphing calculator. So I'm going to come over here and pull up the graphing calculator and show you what the graph of that looks like. So I'm going to make sure that I show you that I do have x minus 3 divided by x plus 5. You don't have your graphing calculator with you at home, but that's okay because we're going to keep these rational functions pretty simple. I just want to show you what the graph is. Oh, yeah, it's kind of, these graphs are they're going to look kind of funky, but we're going to be able to create these graphs pretty darn easy. And if you look, hey, what's that value right there? That is 0, -3/5, and whoa, it looks like that graph crosses the x-axis. What? Right at 3. I could find that with my table, but what I'm going to do at the table, and what's going on here? Well, what's going on right here is that excluded value. We're going to call that a vertical asymptote. The other thing that it's going to be important for me to know is where does this function go as the x get really good? It looks like it's increasing, but we don't know. And where does it go as x goes this way? So I'm going to change my window a little bit, and we're know about changing windows. I'm going to go, instead of from x equals -10, I'm just going to go from x equals -100. And I'm going to, from 100 to 100, and I'm just going to kind of look at that graph. Whoa, 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 whoa. So let me tell you what this graph does. What happens here are these y values tend to a particular number as x gets big. And as x gets big this way, the y values tend to a particular number. What I'm going to do is I'm going to go to my table. I'm going to make sure that I'm on ask, and I am. And I'm going to come up here to the table, and I'm going to delete these guys. I could have left them in there. And I'm just going to see what, I'm going to put 10 in. That's what the output is, 0.4. I'm going to put 100 in. The output is 0.92. I'm going to put 10,000 in and a 0.9. It looks like those y values, let's put a bigger number in. Looks like those y values are approaching 1. As the x's get big, that's 1 times 10 to the 6th. The y values approach 1. Let's go the x values the other way. Let's go negative 10. Bam. Let's go negative 100. These are my x values. Bam. Let's go negative 10,000. Bam. And look, the y values again approach 1. That's what's happening to this graph. Keep in mind, you can pause the video to see what's happening, to kind of keep track of everything. What's happening as x gets big, this graph is approaching this creature 1. As x gets small, the graph is approaching 1. And I'm going to put that on my smart notebook here, and I'm going to sketch the graph. What happens at -5 is this. And if I go back to this graph, and I haven't talked about this on the graph, but if I go here, something is happening right here. What's happening there is the graph, it looks like it's getting super big. Looks like the graph is getting super small, the outputs, and they are. What we're going to call those rascals are vertical asymptotes. So here's what we're going to do. I'm going to sketch a dotted line here. Whoops. I want the line tool on this. I want a dotted line. I'm going to go that colored. I'm going to go. That rascal is going to be, that vertical line is going to be x equals -5. That is directly, these things are the same thing. X does not equal 5 because the graph is undefined at -5. This x equals -5, I'm going to write it over here. This is called a vertical asymptote. Really, you're going to come to find out that this stuff is pretty straightforward. What I'm going to do is graph what I know, 0 3/5 right here. That point right there is 0 3/5. And one thing I'm going to tell you is that a graph cannot cross a vertical asymptote. I'm going to plot this 0.3, 0. And the other thing I'm going to state here is that that graph is not going to cross the x-axis again. If I look at my graph, here's what it's going to look like. What graph? I'll use green for my graph. And if I look, if I remember what my graphing calculator is doing, I'm going to just come over here. It's positive over here. It's going to do this. So how do I know that? The first thing I know is this thing only crosses the x-axis at 3. It has a y-intercept of 0, -3/5. All I could actually put a point in here. Since this is -5, if I put -6 in here, if I just look at this value at -6, what's the function value? What's f of -6? F of -6 is going to be -6 minus 3 over -6 plus 5. -6 minus 3 is -9, divided by -1 is 9. So this point right here is 6, 9. I know it's positive. Okay, that's that point. This dude here, I'm going to do this line in yellow. I'm just going to make it a solid line. Make it a dotted line. This, I'm going to try to grab a hold of that. This is what the y values approach. What do we call that? We're going to call that guy right there. Well, we know it's y equals 1 because that's what, as x gets big, the y values approach 1. They don't go over 1. As x gets big this way, what's happening to the y values? They approach 1. Y equals 1 is called a horizontal asymptote. So I'm going to go to the next screen, and where we're going to see the same graph, and I have these things, and they're going to ask you about horizontal asymptotes on this IXL, and I'm going to have a Google form to ask you about horizontal and vertical asymptotes. So this guy is going to have a horizontal asymptote, y equals 1, right there it is, and it has a vertical asymptote, x equals 5. The vertical asymptote happens at the excluded values, and the horizontal asymptotes happen, that's what the outputs, that's what the function approaches as x approaches a big number. X approaches a big number. Let me put an empty page in here, and I'm going to show you something else. So if I have this guy right here, I'm going to go same guy. Let's see, and this is what I want to say. F of x approaches y equals 1 as x approaches a really big number. You might have to watch this video a couple times. That's what's nice about videos. And here's how you can do this. What's a really big number? Who's got a big number? Lucy, do you have a big number? Sure you do. Here's a big number. Let's call it quadrillion. And all I know is that quadrillion is a really, really big number. We're going to use craw for short. It's a really big number. A super, super, super big number. Big number. A quadrillion. It's a big number. And I'm going to ask myself a question. What's quadrillion minus 3? Well, if I have a gazillion dollars, if I have $1 million and I give you 3, guess what I have? $1 million. The negative 3 is insignificant. Hey, what if I have a quadrillion dollars and you give me $5? How much do I have? Oh, I still have $1 million. $1 million plus 5 is $1 million. $1 million minus 3 is still $1 million. And I'm going to use that to find the horizontal asymptote. If I look at this guy right here and I want to evaluate the function, which is this is my function, x minus 3 over x plus 5. If I want to evaluate that function at quadrillion, here's what I'm going to do. I want to put that really big number in there. Well, that's going to be quadrillion. Let's get some more page here, big dough. That's going to be quadrillion minus 3 over quadrillion plus 5. What is quadrillion minus 3? Quadrillion. What is quadrillion plus 5? Quadrillion. Oh, what's a real number divided by a real number? What's 9 divided by 9? 1. What's negative 18 divided by negative 18? 1. What's quadrillion over quadrillion? 1. That's why this thing has a horizontal asymptote of y equals 1. Because if I put a really big number in, I'm going to get 1. If I put a really big negative number in, what's negative quadrillion? Minus 3 over negative quadrillion plus 5. It's still going to be negative quadrillion over negative quadrillion. And what is negative divided by negative? 1. It's still going to be 1. So what do we call that? We call that one a horizontal asymptote. The vertical asymptote is the excluded value. A graph doesn't cross its vertical asymptote. A graph can cross a horizontal asymptote, but none of the ones that we're going to see yet do. I can easily find the y-intercept. I can easily find the x-intercept. And I'm going to post another video about these rational functions. The excluded values, you're going to talk about the horizontal asymptote and the vertical asymptotes on the IXL. And then I will come up with another video over an example for a rational function, because we're going to have a Google form, might call it a quiz over rational functions as well. This is going to get you started on this week's IXL. All right, so I will see you soon. Let's see here. Oh, in the meantime, what have I done? Oh, I've gone to the hairdresser. All right, so I will see you. I miss you. I love you. Bye.